Maybe in the next lecture I will try to show you something which is based on these things. I wanted to start and show you how this profile can be made into a drawing. I have another monitor there, I will try to do that. The advantage of this is, once you know the prior art or saying what the others are doing, you will have approximately an idea to start. I am not advocating copying anything. Secondly, if these are all standards which you need to adhere to, typically it could be NEMA, typically it could be industry standard. Suppose you want to buy a PLC, so many numeric controls things are there. You will notice that all of them look a little like each other, a little. Especially yesterday's lecture, if you remember, I have shown you how the leads are taken inside. So, we have some lugs, and all the lugs and all are standardized. So, you have spade lugs, you have regular full hole, then you have a sort of crimping type, and the way the lugs are attached to the wiring and all that. So, your equipment should be completely compatible with or replacing another one. And the other way is that you should be able to make something which can be upgraded directly, and that is where the hot plug-in will come. You should be able to remove 4 screws, remove your drive and put another drive and have all the things back in shape. So, in those conditions it is very much essential for you to have a look at all these various catalogs that are already available here. I now try to make it into normal page width, okay, and then try to go through a little faster. Can you see here? So, we have usually all these things, how to order. See, if you can think of something, you can probably, it is already existing there. So, you just need to, so we have heat sinks for any device you can think of, mounting hardware, DC-DC converters. Somewhere else I will show you about what is called a brick. Okay. You have seen here quarter brick converters on the market. If you are in the military hardware, you will probably come to these items saying what is a brick and what is a brick power supply. Permit me to go back a little. Yeah. Seen, very interesting. Mounting slot accommodate 2 patterns, something so many inches, fitting the vast majority of quarter brick converters on the market. These are all typically something which is used in the aircraft industry. I do not know how the thing is available. I mean, so another important thing you have seen here, what is written here, which is very critical. If you see here, the heat sinks are, the fins are horizontal, and you see about the same dimension, but in this case the fins are in the vertical direction. So, it is for you to now decide which is the one that will, what you call, in the final configuration you do, though it is quite possible that in case you have forced convection, you can overcome all this, but even in the case of forced convection, still if it follows the natural gravity, especially in static installations, it is very critical which direction the thing has been made. If you have the, what do you call, the facility to get all these machining done, and you see here this profile seems to be having 36 mm width and 57 mm length, and in connection this is same 36 mm and 57 mm. Now we need to check now in the extrusion direction. So, this extrusion direction, the direction is like this, you understood, no? It is like this. In this case the direction is like this. So, you need to select the proper extrusion, one way. Secondly, otherwise no, you can go to these people at least for small runs, and if you are not competing on price, anyway you know who can beat you at the price thing. So, you can always procure it from these standard suppliers. Advantage of the standard suppliers are most of them are alternate supplies are available. So, here for power modules, IGBTs, relays, these are something else called the bonded fin heatsink, which I suggest no you read up before I repeat, you read up. Seen here no, again, well I will not call it a goof. There are you see we have this beautiful thing no, meant for forced convection, but of a different configuration, and you see here we have a mounting system here and we have another mounting hole here, and instantly if you were to mount any power semiconductors, likely that you will only stick to this region. If you stick to this region, so the whole thing has been fairly optimized, total area is optimized. These profiles you need to, it is easy for a starting point. Here directly cubic feet per minute he has given, okay. Then power dissipation. So, that particular industry it uses that what you call LFM, or in this case the cubic foot per minute it gives. So, that could be liter per minute or something, here it is cubic foot per minute. So, you see here if you see these, they has given a very convenient picture for us to even understand. I will see if I can enlarge it, that you see what you have in the front. We have a pen for comparison, then I am not very sure. This looks a little like an IGBT switch, then I am not very clear what it is. And the very critical thing to observe is, you see these two mounting holes here, these two mounting holes most likely fit these two miraculously. So, all you need to is buy this and do a little bit of calculation on the losses, especially switching losses, mount all of them, mount 3, 4, 5, 6 of them in a row, and then probably you can even mount something back to back, attach a proper fan, I loosely use the word fan, and you are in manufacturing business of whatever devices you want. I will now take you to another what do you call catalog. This is by Avid Thermalloy, Avid. So, you see here already a design for engineer seeking a complete off the shelf solution for industry standard 8th brick converters, means it is a 1/8 of a brick. I am not very familiar with what it is, probably if you check again same thing here, you see here this is probably mounted facing this direction, this is mounted facing this direction. So, we have high fin density as more surface area, fin geometry improves system airflow and reduces fan cost, which is very important. Hole pattern fits 1/8 brick DC-DC from manufacturers Delta, Emerson and Tyco. Lengthwise and crosswise fin orientations in 3 fin heights allow precise match of the application. This is where it is critical. If all of them have about the same pitch, you can neatly stack one over the other. That is where the 8th thing comes. So, probably you can have 2 rows and I am sorry 4 rows and 2 columns, and you can have all the fins in the same direction. So, if you see very nicely that multiple of 4 in one and multiple of 2 and the other approximately fits whatever the dimension is, which fits the electronic what do you call it, things used in the naval as well as aerospace industries. Typically most aircraft and most naval applications have this. So, you put it inside, it matches very well. So, if you are in the what do you call in the packaging field, you will probably be an expert in mechanical or electrical, one of them, but you can at least seeing all this, if you are an electronics engineer, you can understand, and then you need to have a little bit of overlap, saying you have to know what they are working on and what you are working on, and it is a matter of choosing one. And then this is where it is, if you ask me, do not attempt to copy these things, because the material itself is very, very highly developed. And you have seen here was a few small tricks which they make. If you see this mounting dimensions, it is an oblong hole which is small 0.4 mm pitch difference is there, and then you see this way there is a significant difference is there between two centers. This one is what do you call, I am not very sure, probably it is 15 mm and this is 12 mm. So, depending on your pitch, the way you drill and all that, all of them can equally very well be stacked easily. So, I can move, probably the center one could be the standard and all other things, two movements you make, and then it is unlikely they will clash with each other. So, these are all the things which somebody has worked for you, and then you can easily, I feel it is very convenient for you to understand these things. So, now allow me to stop this and see, go to, since I am making it from our local this thing, I wanted to show you that not long ago this was very much current about it. So, if I show you some of the lower cost audio, professional audio, but lower cost and all that, probably this sort of thing is very, very common for them. Seen that? This profile and the one there and this profile are about the same. You have two mounting holes, then a beautiful what do you call base here, 6.5 millimeters wide, and this is 135 mm, and then nicely if this is inside of the equipment, imagine this part of it is the base, this portion can be inside the equipment, and you can probably mount your power devices here and then make some arrangement by which you can probably have a driver PCB and all. This whole thing is enclosed from here. So, if you just cover this portion, you take something and just cover this portion, it is very much easy for you. You have all this many fins and this area for you to dissipate heat, which is how you start. So, there is a lot of what you call details, so many of these are available, and same thing here, you have seen this, probably somebody has ordered this, and you see the difference, this has a mounting flange built into it, does not have a mounting flange built into it. So, what did they do about it? Probably in that particular application, instead of buying one with the mounting flanges, instead of buying this with the mounting flanges, it is much better, you have 92 mm here, and then you take a call on how you mount these things. It can be inside a rack, and directly you can have a mounting plate here at the bottom, and then the whole thing can be made. So, we have huge number of manufacturers and things like this. I am not very clear if somebody has actually made any calculations or anything, what you see here. I feel happy when I see such things. So, I have two options, you have to make one more mirror on top, and then you put a huge fan, and then the fan, as I have explained to you directly, oh, hey, what happened? Huh. It shows 178. So, there are some mounting holes and so on like that. So, if you have a 180 or some other equivalent cooler, you just can package the whole thing, probably something which is having a suction that side and having a force this side, and then you see the way these have been made. These can easily be tapped. You put something and tap it. Once you tap it, both sides you can mount it easily, and this is used for a nut. So, these usually typically some things like that you can put a big nut, mount it here, otherwise you can put a strip here, and depending on all the proportions have been adjusted for the locally used things. Some places you have a 6 mm bolt, other places you have a 1/4 inch, they are about the same. Only if you are somebody who has maintained, who has found this inside, you know that Murphy is always about work. Whatever item you have, the other matching one will belong to another system. And if you have a 1/4 inch nut, I am sure you will have a 6 mm screw which does not go inside, it just keeps give a couple of tight things and it starts slipping. And the reverse is, if you have a proper 6 mm nut, chances are you end up with a 1/4 inch screw which does not go inside. So, if you now go to the catalog, this is only the extrusion catalog, this is not the people who make the extrusions cut and mount it for you. So, you can always go back and see what best you can do with this extrusion. So, I will now try to go back to the width of the page and try to take you down, and you see here diode heat sinks, then some other what do you call, various types of boxes. Obviously, here you have a power mounting thing here, something else here. This looks like a place for a PCB to go inside this. So, if you can think of it, it is probably already exists somewhere. You have seen this, no? Anything you want probably exists somewhere. Getting more and more interesting. There is a huge mass of material at the base. So, this is probably made for a specific application from a supplier. Now, if somewhere here, if you draw a median and then try to make a hole, probably things like a 3/8 inch stud and all that happily go inside here, and these are specifically made for some power industries. Power industry is invariably used. This is one more thing which you commonly see in all our equipments, in all the small equipments which I have shown you earlier. So, on one side we have a printed circuit board, and then we have all our power devices mounted here. There is a plus point and a minus point. Plus point is that you have a mounting flange. Minus point is, if you see the cross section of this versus the cross section of it, this is not very effective. Having a big useless base like that is ineffective. It would have been logical if the same 7 mm were probably made here at 7 mm, or in fact I would prefer 8 millimeters here. So, while I will not call it a big bloomer, this is probably not the best place to mount your power semiconductor. Very rarely you need to mount them on the flange here. This flange can be used for holding this or holding a cover or anything. Ideally, I would probably locate the center point of it, and somewhere along this, this could be a place where I will mount the power semiconductors. Now, how do I mount and how do I do everything? No, it is for you to use your creative techniques. So, generally what they do is, they one more time they mount it on another aluminum block and probably give a clearance here. One of the fins you can give a clearance here and have the aluminum block tap here put a screw outside and then push it here, and then in between you provide the necessary heat sink compound. So, you have power devices mounted on a thermal bridge. The bridge can be as wide as you can have, and then directly it is in contact. Probably put minimum of some 4 screws in the 4 ideal vertical. Again I will talk about the area points. Then once you tighten it, now this whole base is for you to transfer heat to this. So, what looks very simple is actually a lot of it depends on your own what you call manufacturing technique and your own design capability. Things with very small these things are also available. You see here, for example, instead of wasting thing on a flange there, they have given something here. Now, it is for you, it is very easy for you to mount some power devices starting probably here, and you have fins on both the sides. So, they are thin and long. Generally thin and long means natural convection, and then you have a beautiful base here. So, you have a what can be highly effective fin in natural convection. If the base is thick, you have a forced convection. So, this is getting more and more this thing. It looks like something from a fantasy movie, but it is not. All of them are highly functional, meant for a particular application. So, you see here somebody probably has ordered that somebody has thought about it, ordered these things here. We have a large area of cross section. As it goes here, maximum this thing is there. After that something goes here, and then they have a huge mounting base also. These are all typically so has optimized it. To me, a lot looks like combination of method of manufacture and combination of other things. See here, for example, if it were in the center, there would have been some advantage. Why they have offset it is with the other thing what I was talking to you about, how they design. So, when you talk about design of heat sink, it is not just about an equation. Honestly, there is no equation which directly pops out a heat sink for you. If you are looking for something like that, now you see this is again one more thing meant for a drive. So, thickness is very small here, only in 20 mm, but you have this, and if you were to keep a nice cover in this, you have something which is panel mounted at the thing, and then heat sink in the back. So, this is would be my favorite. So, if you go down, anything you can think of probably exists. Now, the second question, I am sure which is there in all your minds, how do we get it? I too have no idea. Me being an academic, I am happily insulated from reality. The reality is, I do not know where to buy or anything, but for our requirements or for your requirements, if you are a professional, you can always go back to a supplier who will supply these things. And luckily in the new economy, somewhere around in the world, somebody probably stocks these things. Just like you are doing in your hobby electronics, things are available. It is not as if I am not fully insulated from the system. And for your first piece, probably you can start with maybe take an aluminum block or take another heat sink and then try to cut fins, mill fins and make an optimum size, or as I told you, look for the prior art and see what else people are using it and then make your things. You can optimize it. If the weight is too much, you can remove unwanted things. If the heat transfer coefficient is not good, then they have put these fins and all that. And if you still have the patience, you can make a model and run a CFD analysis. Very much possible for you to make anything here. You see here some are simple looking, small and cute. Some are they do look. This is something just now I noticed. I am not very clear as to why somebody had to make somebody had to make what looks obviously like a piece of art I do not know what is the function of this or why it is. It has been probably made for somebody. I cannot see any logic why at the end of the tip it is wide like that. Maybe something else also comes here. These are of course, you know, they are mounting holes. So, I will just quickly, I will try to scroll through. Okay. These are real, you know, beautiful. There is a curved monster here. So, it is for you to take a call, see why that was made, and you see here anything you can think of, no, somebody had made it. And you see there is one more interesting thing. Two of them, if you keep them back to back, they fit miraculously together and you have a beautiful heat sink, and then you see here we have a nice curvature also here, and probably this forms one, what do you call, I will call north and west, no, northwest corner, other no, the what do you call east and south, or in the case now we can call 12 and 9 position, and then the 3 and 6 position, it gives it back to back. We have a beautiful enclosure which uses the same profile, but you can attach two things together. Now, how do you mount it everything? No, if you have the CAD drawing, usually all these things will have regular vector CAD drawings also available. If you do not have the vector CAD drawing, you can always scan this, convert it into a vector by tracing it. Alternatively, there are programs which will catch the, what do you call, the border and convert it to a vector. It will not be very good, but it is enough for you to make your own assumptions. So, in a way I am happy that this is taken from a local catalog. I have still not been able to make out what this, you know, beautiful shape, whether it is only for a, I do not know as industrial and why this, you know, fancy shape is there, or they are trying to violate some design registration or something. Probably some design there, no, requires it, or some of the biomedical equipment, no, like things what they sell. You see here, these are all things which mechanical engineers in conjunction with electronics engineers probably like it. I am sure when once you see this, now you think exactly this is what I was looking for. So, probably no, I will just go through this, after that I will stop. Oh, looks very interesting. No clue what it is, but obviously there is a good, very good use for it. Some device for mounting. Typically things like this, no, can also be used as heat bridges, what I was talking to about. So, this part of it can contact the heat sink wherever we want. This part of it has the mounting devices and all that, and you can now try to mount your own, what do you call, devices on both sides, and then the whole thing can now, you know, you can probably drill a hole here, and then attach it to the heat sink on the other side. So, this is a beautiful bridge. Only advantage for you is already these holes come pre-extruded. So, you need not do anything, you can use even a self-tapping screw. Put a self-tapping screw here, only here, no, the actual tapping is required, cut it to length, and you are in good, what do you call, good company. Your equipment will be as good as other things. This, I do not know whether a capacitor goes inside or why that particular things have been ordered. So, I suggest you go to the Ambika, what do you call, traders, go to Jindal catalog, and most of the things that have been made over the years are all available in the catalog. And if you order, since the tool is existing somewhere, somebody else will be able to make the extrusions for us. So, permit me to stop here so that you have a look at it, but my suggestion is please go through all the catalogs, and then towards the end of the session when we upload it, I will try to see whether all the links can also be given in a text form as they were extracted now. You can use them, and since they are all public property, and I am acknowledging that the whoever has provided it has spent enough time, I am using them freely, and I expect you also know you have to, I suggest you, blind copying will not help, because that process of the material 6063, most of them use 6063 aluminum, which is very different from the structural extrusions, very different from normal structural extrusions. And then randomly, if you take a soft aluminum alloy and then try to mill things out of it, milling itself will be your first problem. Secondly, composition will be another problem. Next, the way the thing has cooled down and the heat treatment and the what do you call temper T1, T2 conditions are very different. So, they behave very different from the professional heat sinks. So, thank you. Next session I will see, you see here that heat sink which is on the desktop, it is possible for me to bring it and use it as a element for tracing those things. So, I just try to maintain the same dimensions 174 and 28 mm here, and try to recreate this on my screen here. Once I recreate this profile, it is a matter of extrusion, and then after that, depending on the our requirements of how to what do you call, how to configure it. Will this extrusion face the back, or will this form the sides, or it will come on the front, or it will be directly on top. I can reconstruct a whole what do you call equipment directly from this. So, I will stop here. Thank you. So, let us meet again in the next session. I will try to complete one of these experiments and then try to show you, and eventually if data is available about what is the length and then what is the thermal resistance of that, I will tell you practically how an equipment is made. Very rarely people start with the fin height and this and try to calculate the what you call combined convection and what you call conduction and a little bit of the this thing, and try to make things. That is very cumbersome. Only in maybe if you have a satellite or if you have some real mission critical applications, like maybe I do not know exactly, I am not into armaments. Very rarely anybody runs these things. However, there are people who do these things. So, obviously in our case we have students who will be happy to do the modeling for us, and we can give them also as an exercise and they will learn a lot. So, thank you.